All right, so this is kind of the crux of what we've been doing. We've been stretching and shrinking, and this is a V shape, and these are all the changes that happen to it. Here's an XY chart I made of the points for it, and here's a little sketch of the graph. You'll have to do actual graphing with carefully plotted points, like here and here and here. You'll have to have 5 of them when you have a absolute value function. All right, I'd like you to give you one like that and see if you can handle it. Let's say f of x was negative, let's say 2, absolute value of 3x, absolute value minus 5. All right, first thing I want you to do is just tell me what are the 1, 2, 3, 4 things that need to happen in what order. And then I'd like you to make a little sketch of it. Does it look like this, or where is the V shape? Just make a sketch. And last, I'd like you to make an X, Y chart to find 3 points. Normally you're going to have 5, but I'll save you some time. Just find me 3 points that would be on this graph. All right, I'll pause for a second while you work on that. Okay, I'm back from the pause, and I'm going to at least start this. Should start on the inside. If you start on the inside, you're going to say that this is not 3 times wider, because it's counterintuitive. So it's 1/3 as wide. So what you should have said is that is it horizontal or vertical? It's horizontal on the inside and vertical on the outside, which also includes out here. Horizontal on the inside. So that's a horizontal, not a stretch, but a horizontal shrink. How many of you had that right? All right, almost everybody. And the last thing is, if I say shrink, should I say a shrink of factor 3? No. What's the shrink factor? 1/3. You can't use a 3, because if you multiply something by 3, it doesn't shrink. If you multiply something by 1/3, it shrinks. So it's a horizontal shrink factor factor of 1/3. All right, second thing I would do, I'd move to the outside, and I would pick up one of these two. And it does not matter which one's first. But I would, generally speaking, stretch before you stretch before you flip. And so that's a 2 times taller, and that's a vertical stretch factor 2. And then the 3 is a reflect. It's an up-down. It's like this way. It's an up-down flip. And so that's a reflect over the x. And the last thing is that minus 5, which is down 5. Be honest, how many of you had that perfect? All right, that's about 10 of you. So it's about 1/3 of the class. So we should try another one in a minute. But for now, did you get any points on the XY chart? Raise your hand if you did. All right, many are done with that. If you did not do it yet, hurry up and do that while I'm making the sketch. Okay, the quick sketch. The quick sketch is basically a V, and it's just a matter of where it is and if it's been flipped. It's a V, and I'm going to do all these changes in the right order. First thing I would say is make it narrower. So my V's got to be narrower, so it looks kind of like that. And then it's got to get flipped and stretched taller. So if I flip it upside down, it's like this. Stretched taller means it's stretched like this. And the last thing is down 5. So it's sort of like that, a really pointy V that's going down there. So I'm going to clean that up and make it just that last one. Raise your hand if you had that for a sketch. Okay, good. And then the points. Raise your hand and give me a point. Who's got one? Yes, sir. All right, if I put in a 0 for x, your claim is I will get -5. I'm going to check you. Put in a 0 right here. I get 3 times 0 is 0. Absolute value is 0. Multiply by this makes it 0. The whole thing is 0. -5. Very good. So 0 minus 5 makes -5. You are correct. Give me another point. Who's got a different point? Yes, sir. -1, and then if this would make -3, absolute value of that is 3. 3 times -2 is -6, -5, and -6 makes -11. Is that what you said? Yeah. All right. And who's got another point? Just give me one more. Come on, somebody else has another point. Yes? Okay, if I put in a 1, +1, how could it come out to the same thing of -11? Well, because when we do absolute value here, it didn't care if it was a 3 or a -3. It came out to 3 either way. So then it times it by 2 makes it -6, and then you have the -5. So yeah, you're right. All right. So if you were to graph that, does that actually match up with my sketch? 0, -5, dot right there. Yep. -1, -11. Okay, it's hard to know if that's down 11 or not. But +1, -11. Yeah, it's all matching up. Do you see how well that checks you? I mean, because what if I made a mistake and flipped it the wrong way and I thought it was a right side up V right here? Okay, you know by checking with that XY table. That's really handy. All right, this time I just want you to do the XY table to figure out where this complicated looking function would be. Just an XY chart. I suggest you use even numbers, fairly biggish even numbers, because it'll work out the nicest. Pick anything you want for X, but if you make it fractions, it's going to be a real pain. You know, the squaring in is really making it hard. I'm going to change it. I'm sorry. Don't square it. Make this absolute value. Because that squaring is making the numbers really big, and then they're almost always odd, and then you have to take 1/4 of that, and then that's really hard. So my point here is you need to understand how to do these XY charts. They're very handy for any kind of graph from now on all the way through calculus. If you can plot XY points, you can graph anything, even if it's really tricky. Okay, so my favorite number of all to put in there is the one that makes it easiest. Which one is that? 0 would be easy. 0 is really easy because 0 times anything is 0. All this becomes 0. 0 minus 2 is -2. That's easy. Okay, but you also said 8. I agree, that's an easy one. So I put in an 8. If I put in an 8 here, 8 goes in here. 1/2 of 8 is 4. Absolute value of that is 4. And then 1/4 of 4 is 1. And then 1 minus 2 would be -1. Is that what you got? All right, good. Anybody else have a good point they could tell me? 16. Okay. Put in 16. You take 1/2 of 16, that'd be 8. Absolute value is 8. 1/4 of 8 is 2. 2 minus 2 is 0. Raise your hand if you had that one. Okay, good. I think you get the idea. I hope you get the idea. Because if I asked you what that looked like, a lot of you'd be like, ooh, I don't know, it's twice as wide, and it's 1/4 as high, and it's just getting confusing what that looks like. But if I just graph these points, I'll know what it looks like. Graph enough of them, connect the dots, you got it. Okay. Let's do a function in a function. Let's go with f of x is going to be the new function 1 over x. Let me make sure you get that function. Do you get the parent points of this? There's only 2. You know what they are? Remember what this guy looks like? Generally looks like this. So what are the parent points? -1, -1, and 1, 1. Good. And as long as from there you just get closer and closer and never touch the axes, you're a little slower and more careful there. So this is kind of curving out too much. Now it's not good. It's basically about like that. There's something called asymptotes in here that you can't see because they're right on top of the line. But if I were to move this graph like left or right, I'd be able to see it. So if I go f of x equals 1 over x minus 4, and then let's go plus 1. How do I do that? I would take the 2 parent points, which are these guys. Boom, boom. And I would move them where? All right, shut your iPads. So many people are drifting right now. I need you with me. This is hard. I only have like 2 more minutes of instruction. You need to be with me on this. All right? Do you know that this generally looks like this? You get that? Okay. Now, where am I moving it? Where do I start? On the inside or outside? Inside. So I'm going to move it, what's that? Right 4, and then what? So I'm going to take each of these points and move it right 4, up 1. See how I moved that one? Right 4, up 1. It's actually going to be... Okay. I think something's wrong. No, that's okay. That's okay. I mean, get these erased. Do it there. Okay, good. Now, what do I need on there to finish this? Asymptotes. Now can you see where to graph it? Once you have the asymptotes on there, it's so much easier to see, okay, now I just get closer and closer and never touch. Try to do it without the asymptotes, you'll be doing it at your own peril. Very likely you'll screw it up. All right. So what if I have one function inside of another function? I got to know the x cubed function too. Let's say that you had to just graph x cubed. Do you get that there are points that kind of look like this for the x cubed? Do you get that? If you don't know what they are, there's three big ones. They go like this. The origin and then negative 1, 1 and positive 1, 1. The other one only had these two, you know, here and here. But this one's got an extra point in the middle at the origin because if you put in 0, it works. And the other function, if you put in 0, it didn't work because it was 1 over x. Can't do that. 1 over 0 wouldn't have worked. Okay, so anyway, there's three main points. Boom, boom, boom. And then you go over 2 and then up 8 because 2 cubed is 8. And then you go 2 to the left and you cube it and you get negative 8. So it's down here. So there's your 5 parent points. Now, here's the hard part. What happens if I do this? F of x is 1 over x. G of x is x cubed. What's f of g of x? Well, which function goes into the other one? Which one's on the inside? It's been swallowed. G got swallowed. So this one has to go inside of this one. So what's it going to look like? 1 over x cubed. Good. Now what's that graph? Now, I don't know. So this is kind of brings up a good point. What if you're supposed to graph something you don't even know what it looks like? What can you always fall back on? X, Y. So you x, y. It is almost like cheating. It's really handy. Okay, so if I take any number I want for x, can I put in 0? I can try it. I'll put in 0, and then when I get 0 cubed is 0. 1 over 0, that's an asymptote. Okay, see there's an asymptote on this thing? You get that? Okay. Now let's try another number like 1. And 1 cubed is 1, and 1 over 1 is 1. That was easy. 1, 1's on the graph. And you just keep on finding points, and eventually you know what it looks like. You don't know what every graph looks like ahead of time. All right, so I'm going to put in like a 2. And if I have a 2, it's going to become a 8, and it's 1 over 8, so it's 1/8. 2 comma 1/8 is on the graph. Stick in negative 1. Okay, negative 1. Negative 1 cubed is negative 1. 1 over negative 1 is negative 1. Negative 1, negative 1 is on the graph. So if I sketch this thing now, let's kind of see what it sort of looked like. I have 0 as an asymptote. I can't even draw that. 1, 1 has a dot. 2 comma 1/8 is down here. Negative 1, negative 1 has a dot. And it looks to me like it's a lot like this guy, except it's been changed a little bit. I'd have to graph some more points to find out. Get the idea that you can just use the XY chart. If you get lost, go to this. It'll tell you what the answer is. Just have to keep on graphing points and connecting the dots. All right. So your homework is this packet because the iPads have kind of sucked lately. So I've got a packet for you. I'll pause for a minute while I am. Okay, so we're doing number 2 in that packet, and it says negative square root of 1/2 x. All right. Do you remember what the square root generally looks like? I hope you know it goes like this, and then you go over 4 and up 2, and over 9 and up 3. So generally, there's my square root. And what am I going to do? Make it wider or narrower? Wider. Going to make it twice as wide. And then what's that negative going to do? Make it flip. Which way? That is on the outside, so it's up, down over the x-axis. So basically, it looks something like this, but it's hard to know exactly where it is. What do you think I'm going to do? XY chart. And I'm going to choose wisely because I have to take half of whatever number I put in there. So I may as well choose like even numbers so that it works nicer. So, or 0 is a good one. Stick in 0, what do I get? 1/2 of 0 and then make it negative, and what's that? Yeah, negative 0, okay. And then I'm going to put in like 2 because I can take half of that well. So what's half of 2? And then I take the square root of 1, which is 1, and then I make it negative, makes it negative 1. Do you see that I was kind of right in where I estimated it? 2 comma negative 1, but maybe I went a little too low. I think I went, yeah. 2 comma negative 1's right there. And 0, 0's right there. And now I'm going to try, what's another good number? 8. 8's a goodie. Because otherwise we're going to have to do the square root of 2. And I don't know what the square root of 2 is. So anyway, half of 8 is 4, and the square root of 4 is 2. And then make that negative 2. 8 goes to negative 2. Oh yeah, I made mine way too low. So the real answer is like that. That's why sketches are totally different. All right, I'm going to pause for a minute. I'm going to do another one, number 4. Go ahead. Shh, hey, gentlemen, quiet please. Number 4. All right. So on this one, I'm going to start by pulling up a graph. Let's see if I can find a good one here. This will be a good one. And if I was going to graph this, it's a V shape, and it's been moved to the right. So generally speaking, it's moved to the right. No, left 1, and then down 2. So it's something like this. But you know what I'm going to do to get my exact points? XY chart. Now, could you do it the other way? Sure, but I think you're going to make more mistakes. All right. It's good to know where it generally is. So now I'm going to start thinking, okay, well, I need negative numbers, like negative 1 or negative 2 or something. I stick in negative 1, and I get 0. 2 times 0 is 0. Absolute value is 0. 0 minus 2 is negative 2. And the faster you are at that, the better, but you don't have to be light speed. You just grind it out. Okay, now if I have negative 2, negative 2 plus 1, negative 1. 2 times negative 1, negative 2. Absolute value of that is 2. 2 minus 2 is 0. So negative 2 makes 0. And actually, I hit that one perfectly. Look at that. Negative 2, 0. And then this one, negative 1, negative 2. I missed that one pretty badly. Okay, now I'm going to stick in 0. I put in a 0 right here. That'd be 2. Absolute value is 2. 2 minus 2 is 2. No, 2 minus 2 is 0. And it should be going through 0, 0. That makes some sense. It's a V shape at least. Now I'll probably do one more point so I can get the pattern here. They put in a 1. Put in a 1 right here. 1 plus 1. Recording. 1 plus 1 is 2. 2 times 2 is 4. 4 minus 2 is 2. So 1 comma 2. And it's right there. So I connect those red dots. I'm starting to get the idea where the V is, and I can just keep the pattern going like that. There we go. The blue one was just a rough estimate. I'm going to get him out of there. It wasn't very accurate. There we go. Okay. It's got 5 points. Good enough. Wait, it's only got 4. I need one more point. I put a point right there. Yes, sir. All right, and a lot of people ask this and are kind of baffled by the results. Did you know that if you put a 2 here, that stretches your graph up twice as tall, right? What if you put a 2 in here? What does that do? It makes it half as wide. But did you know a V shape that has been stretched up twice as tall? Here's a normal V, right? If I stretch it twice as tall, it looks like this. If I make it half as wide, it looks like this. It's exactly the same. Isn't that weird? And if you think about it, it makes sense. If I put in a number like 8, do you get that the answer to that is 16? And I put an 8 here, what's the answer to that? 16. Same exact thing. So in the case of a V shape, absolute value, that actually works in parabolas too. If you actually put a 2 on the outside or the inside, it's the same exact answer. I know that's weird, but it's true. Put in another lemma, like 10. See what happens if I put in 10. That's going to be 20, and this is still going to be 20. Either way, it's 20. How about if I put in a negative number, like negative 10? Absolute value, 2 times absolute value will be 20, and it's still going to be 20. Same exact thing. If it keeps coming out with the same answer, it is the same function. So it doesn't matter if it's on the inside or the outside. Say that again?
It's like 2 times 8 squared would be
So y equals 2x squared like this. Is that what you're saying? Versus this. You are correct that this, when I square it, is going to be different. You're right. And I think, so maybe it's only the V shape. I think it only works on the beginning of the parabola because it's a 1. So, okay, I should stick to just the V shape does this. Anyway, so you're right. This one would be different. Because if I put in, for instance, 8 here, I'd have 8 squared is 64 times 2 is 128. Put in an 8 here, it's 16 squared, which is way bigger than 128. So you're right. Thank you for correcting me on that because I didn't want that to stay on the video incorrectly. Yes, sir. Yep, read me number 5. 1 over x minus 2 and then plus 3. All right. Generally, it's this shape. And then I got to move it generally 2 to the right and up 3. 2 to the right, up 3. Do you get it? Generally is in this neighborhood. Now take a guess what I'm going to do to find the exact points. XY chart. It really does work. Okay. What do I put in? X is 0. That's going to become 1 over negative a half is negative a half plus 3. 3 and negative a half make total of 2.5. 0, 2.5. Look, it's on the graph. Now, what are the parent points? It looks to me like it should be like over 1 and up 1. So maybe if I try putting in 1, it'll be interesting. Okay, so I'm going to put in 1. I put in a 1 right here. 1 minus 2 is negative 1. 1 over negative 1 makes negative 1. Negative 1 plus 3 is 2. 1 comma 2. There we go. It's on the graph again. All right. Now this one actually with the XY chart, it's going to be a little tougher because you got to get so many points to make it work. That I'd probably just say on this one, maybe it's better to just say, I know my 2 parent points, and I'm going to move them. Do you get that these are the 2 parent points? I'm going to move them. I'm going to move them 2 to the right and up 3. So they're all both going to go 2 to the right and up 3. 2 to the right and up 3. So I end up with there and there. And then once I get those parent points moved, asymptotes, asymptote, asymptote, and from there I hope you can just see it begging to be drawn in right like that and that. You know, the XY chart does work on this, but I think it's too slow. On this kind, I probably would have just moved it. Okay. Got a bunch of problems to do. I gave you ones you could skip. Specifically in your class and any of my kids at home listening, here's the ones that you could skip. Remind me again, what did I tell you in your case? 1, 3, 5, and, no, 1, 3, and 7? And 11. 1, 3, 7, and 11 were all skips. I think the rest of them you really need to do because I hate to cut something out and have it be important on the test. So, all right, that's all I got for you for today.